Hello, my dear students. Welcome back to chemistry class. Can you say a few fuels what we are using at home or to run the automobiles or in industry? Yes, at home we are using LPG, kerosene, etc. To run the vehicle, which are the fuels we are using? We are using petrol or diesel. In industry, we are using coal, diesel, etc. And I'll ask you one more question. Have you seen a candle is burning? Yes. Have you seen a coal burns? Can you see the difference between burning of a candle and a coal? Yes. A candle burns with a flame, but coal burns without flame. So today in this lesson, we are going to learn about the chemical process of burning and the types of flame. So let us learn the lesson, combustion and flame. In this lesson, today we are going to cover the topics: what is combustion, combustible substances, ignition temperature, and inflammable substances. So let us see what is combustion. You have learnt in your lower classes burning of a magnesium ribbon. When a magnesium ribbon burns, what is produced? Magnesium oxide is produced along with the production of heat and light. And if a coal burns, what are the products? It produces carbon dioxide, heat and light. You know, coal is a form of carbon. So when it is burnt, carbon dioxide is produced along with the heat and light. Now let us see the definition of combustion. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. You know, it is a chemical process. Why it is called a chemical process? Because a chemical reaction means there is formation of new substances. In the previous example, we have seen magnesium burns, magnesium oxide is produced. When coal burns, carbon dioxide is produced. So during this reaction, heat also produced. So a chemical process in which a substance reacts with oxygen to give off heat is called combustion. Sometimes light is also given off during combustion, either as a flame or as a glow. As we have seen in the previous example, light also is produced. Now, what are combustible substances? The substance which burn in air is called combustible. It is also called a fuel. As we have seen in the previous example, magnesium and charcoal are combustible substances. Can you name a few more examples for combustible substances? Yes, wood is a combustible substance. Then petrol is a combustible substance. So you can name many examples for combustible substances. Now I'll ask you a few questions. Whether food is a fuel for our body, we have seen already these combustible substances are also called fuel. Whether food is a fuel for our body, we all know that energy is required to do work. From where we are getting the energy? From the food. How we are getting the energy from the food? Because food is oxidized. It reacts with oxygen and it is broken down into simpler molecules. During this reaction, heat is produced. That energy only we are using to do the work. So, food is a fuel for our body. In our body, food is broken down by reaction with oxygen and heat is produced. So, food is a fuel. Next, one more question. The sun produces its own heat and light. We all know that. Is it also some kind of combustion? We have seen the definition of combustion, heat is produced. But the burning of sun, the production of heat and light due to sun, that is a type of combustion? No, it is not a type of combustion because here the sun is not reacting with oxygen to produce the heat and light. Then how the heat and light is produced? Due to some reactions called nuclear reactions. So the production of heat and light by the sun is not an example for combustion because in the sun, heat and light are produced by nuclear reactions. Now, here are a few substances. You have to classify them into combustible and non-combustible substances. Wood, paper, iron nails, kerosene oil, stone pieces, straw, charcoal, matchsticks, glass. Let us take one by one. Can you say wood is combustible or not? Yes, it is a combustible substance because it reacts with oxygen to produce the heat and light. Paper, it is also a combustible substance. What about iron nails? It is a non-combustible substance. Kerosene oil, it undergo combustion. So it is a combustible substance. What about stone pieces? They are non-combustible. Straw, combustible. Charcoal, combustible. Matchsticks, it is combustible. And glass, it do not burn, so it is not a combustible substance. Let us see. Wood is a combustible substance. Paper, combustible. Iron nail, non-combustible. Kerosene oil, combustible. Stone pieces, non-combustible. Straw, combustible. Charcoal, combustible. Matchsticks, combustible. And glass, non-combustible. Now here is an activity to show that air is essential for burning. So we have taken here a lighted candle. We have kept a lighted candle on a table. Put a glass chimney over the candle. This is a glass chimney. This we have kept over the candle and rest it on a few wooden blocks. So this chimney is resting on a few wooden blocks. Here you can see two wooden blocks. On that the chimney is resting. Now next what we have to do? We have to remove the blocks and let the chimney rest on the table. In the figure B, you can see that. We have removed these wooden blocks. Now the chimney is resting on the table. Next what we have to do? We have to put a glass plate over the chimney. Over the chimney, we have kept a glass plate here. So each time you have to observe what happens here. So you can see here, when the wooden block is kept, the chimney is kept on the wooden blocks here, you can see the clear flame here. What is the reason? Here air is available. Air enter through this gap. Second case, when we remove the wooden block, air is not available below. Only little air is available from the top. So what happens? The flame flickers and the smoke is produced because the less availability of air. In the third case, air is not at all available. So the flame puts off or it is extinguished. Let us see the observation. The candle burns freely in case A when air can enter the chimney from below. Second case, when air does not enter the chimney from below, the flame flickers and produces smoke. In the third case, the flame finally goes off because the air is not available. So what does it show? Air is essential to burn. Inference. Inference means what result we are getting after the experiment. For combustion, air is necessary. So how the experiment is done? We have taken a burning candle. We have covered that with a chimney, glass chimney, and The chimney is resting on two wooden blocks, and we have seen in this case what we can observe here. The candle burns freely because air enters the chimney from below. Next, what we have done, we have removed the wooden block. Let the chimney rest on the table. What we can observe here, air does not enter the chimney from below, so the flame flickers and smoke is produced. And the third case, what we have done, again we have covered the chimney with a glass plate. What we can see, what we can observe, the flame goes off. So from this what we can understand, for combustion air is necessary. Next, I'll ask you one question. Place a piece of burning wood or charcoal on an iron plate or tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does the charcoal stop burning after some time? Can you think of the reason why it stops burning? What is your answer? Yes, the charcoal stops burning after some times. Now can you say the reason? Yes, when it is covered with a tumbler, it is not getting the oxygen or air to burn. So it puts off. Let us see the answer. Charcoal or any other object requires oxygen to burn. When it is put in a glass jar and is covered, there is no space to let the air, which contains oxygen, in. After all the oxygen present inside the jar is consumed by the burning charcoal, it stops burning as there is no oxygen supply to let it burn. Now one more question. When clothes of a person catch fire, the person is covered with a blanket to extinguish fire. Why? Here also the same reason. When the person is covered with a blanket, what happens? The supply of oxygen is not there. So the fire will extinguish. When clothes of a person catch fire, his body is covered with a blanket to stop the supply of oxygen. Air in the oxygen, that means oxygen in the air is essential for combustion. We have seen already. In the absence of air, combustion will not occur. The fire will be extinguished. So why the body is covered with a blanket? To stop the supply of oxygen, thereby to extinguish the fire. Next, here are a few questions. Does a matchstick burn by itself? How does it burn? Can you say a matchstick burn by itself? No. We have to rub with a rough surface, then it burns. Another question. Does a piece of paper burn when a burning matchstick is brought near it? Yes, you experienced it. When a burning matchstick is brought near a paper, it catches fire or it burns. Can you burn a piece of wood by bringing a lighted matchstick near it? No, we cannot burn a wood by bringing a matchstick near it. Then how will burn a wood? Either we will pour some kerosene oil or we'll keep some paper with the wood, then it catches fire. So these experiences tell us that different substances catch fire at different temperatures. So we have seen matchstick at room temperature itself it is not burning, but when we are rubbing with one surface, because of the friction produces heat, due to that heat it burns. But this matchstick is enough to for burning a paper. But using the matchstick, we cannot burn a wood because wood need little more higher temperature to burn. So all these shows that different substances catch fire at different temperatures. This is called the ignition temperature. So here we are going to learn one term, ignition temperature. Let us see its definition. The lowest temperature at which a substance catches fire is called its ignition temperature. Is a minimum temperature or the lowest temperature at which a substance catches fire. So below this ignition temperature, a substance cannot catch fire. Now can you tell why a matchstick does not catch fire on its own at room temperature? Because at room temperature it is not reaching the ignition temperature. So ignition temperature should be reached, then only it will catch fire. Why does the matchstick start burning on rubbing it on the sides of the matchbox? Let us see the answer. A matchstick does not catch fire and burn on its own at room temperature because the ignition temperature of matchstick is higher than the room temperature. So lower than the room temperature, a substance cannot catch fire. At minimum, it should get the ignition temperature to burn. So what is ignition temperature? The lowest temperature at which a substance catches fire is called its ignition temperature. Now, have you heard about forest fire? How is it produced? During extreme heat of summer, at some places, dry grasses catch fire. From grasses, it spreads to trees and very soon the whole forest is on fire. It is very difficult to control such fires. Next, let us see the history of matchstick. More than 5,000 years ago, small pieces of pine wood dipped in sulphur were used as matches in ancient Egypt. The modern safety match was developed only about 200 years ago. So let us see the earlier how the matchstick was using. A mixture of antimony trisulfide is a chemical and potassium chlorate and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood. So a suitable wood is taken to the head of that. What is applied? A mixture of antimony trisulfide, potassium chlorate and white phosphorus. With some glue it is applied on the head of a match. When struck against a rough surface, white phosphorus got ignited due to heat of friction. White phosphorus is a substance which catch fire soon. So this white phosphorus, when this matchstick is stuck on the a rough surface, this white phosphorus catches fire due to the friction. This started the combustion of the match. But you know, white phosphorus is a poisonous substance, so it is dangerous for the workers involved in the manufacturing of matches and those who are using it. For the users also, it is dangerous, this white phosphorus. Now let us see nowadays how we are using the matchstick. These days, the head of the safety match contains only antimony trisulfide and potassium chlorate. You see here, white phosphorus is not used here, only antimony trisulfide and potassium chlorate. The rubbing surface has powdered glass and little red phosphorus. So these white phosphorus and red phosphorus are two forms of phosphorus. White phosphorus is very dangerous because it is poisonous. But compared to that, red phosphorus is much less dangerous. So here only antimony trisulfide and potassium chloride is used in the at the head of the match. And on the rubbing surface, what is applied? A few powdered glass and a little red phosphorus. So when the matchstick is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with the potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion. So earlier antimony trisulfide, potassium chlorate and white phosphorus were using. Nowadays, only antimony trisulfide and potassium chlorate is used at the end of top of the head of the matchstick. And on the rubbing surface, what is used? Red phosphorus and powdered glass is used. As red phosphorus is compared to the white phosphorus, it is very much less dangerous. So when it is struck against the rubbing surface, what happens? The red phosphorus, some of the red phosphorus gets converted into white phosphorus. This white phosphorus immediately reacts with the potassium and it produces the uh, heat. Then antimony trisulfide is ignited and start the combustion. Now, a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. We have seen already. So here is an activity. So have you ever seen cooking oil catching fire when frying pan is kept for a long on burning stove? Yes, you might have seen this. It catches fire when a frying pan when we are keeping for a long time. Kerosene oil and wood do not catch fire on their own at room temperature. But if kerosene oil is heated a little, it catches fire. But if wood is heated a little, it would still not catch fire. So this all shows that combustible substance cannot catch fire as long as its temperature is lower than its ignition temperature. When it reaches its ignition temperature only, it catches fire. So kerosene oil, soon it will catch fire, but a wood or to catch fire, we have to heat little more. Ignition temperature of kerosene oil is lower than that of the wood. That is the reason. So here is an activity to show that it is essential for a substance to reach ignition temperature to burn. So make two paper cups by folding a sheet of paper. Pour about 50 ml of water in one of the cups. Heat both the cups separately with a candle. What happens to the empty paper cup? What happens to the paper cup with water? Does water in this cup become hot? So what we have done? We have made two paper cups. One of the paper cup, we have poured some water, and both the paper cups we are heating with using a candle. So what we can observe here, the empty paper cup catches fire, it burns. But where the water is kept, that paper cup will not catch fire and the water becomes hot. What is the reason here? The paper is having very less ignition temperature. So when it reaches its ignition temperature, it burns. But here, the heat uh, produced, that is transferred to the water by conduction. Conduction is a method of transfer of heat. And the water, sometimes the water can, if you are heating more time, the water can boil also. So until the water boils, until it does not catch fire. So empty paper cup burns. Paper cup with water does not burn. Water in the cup becomes hot. If we continue heating the cup, we can even boil water in the paper cup. The heat supply, what is the reason here? The heat supplied to the paper cup is transferred to water by conduction. So, in the presence of water, the ignition temperature of paper is not reached. Hence, it does not burn. Empty paper cup burns when it reaches its ignition temperature. So, in presence of water, the ignition temperature of paper is not reached because the heat is transferred to the water by the conduction. Conduction is one of the method of transfer of heat. So, how the activity is done? Here we have taken two paper cups. One of the paper cup we have taken water. We are burning both. So, we can see the empty paper cup burns. And where the paper cup with the water does not burn because the heat is transferred to the water. So, its ignition temperature is not reached. Now, let us see what are inflammable substances. The substances which have very low ignition temperature and can easily catch fire with a flame. They are called inflammable substances. The substances which have very low ignition temperature and can easily catch fire. You know, petrol, alcohol, kerosene, the LPG, all these, soon it catches fire because its ignition temperature, their ignition temperature is very low. These are all example for inflammable substances. So we have learned today what is combustion, what are combustible substances, their examples, and we learned the point air is essential for burning. And we learned what is ignition temperature and it is essential for a substance to reach ignition temperature to burn. And we also learn what are inflammable substances. Hope you understood today's class. Thank you, children.